Welcome members to TED Talks. We are still for biology and we are looking at chemicals of life. We are in phospholipids and our main focus now is going to be on phospholipids, very important chemical of life, the phospholipid. A phospholipid is a conjugated, let's call it a conjugated triglyceride, a conjugated lipid. Let's not talk it up to the triglyceride because it does not make it. A conjugated lipid made up of a glycerol molecule, two fatty acid molecules, and one phosphate group. We're going to see how now it is formed. Formation of a phospholipid. Formation of a phospholipid. So I've said it is made from a glycerol molecule. This is our glycerol molecule we have been dealing with. A glycerol molecule. So they resemble with lipids, but this one is a conjugated lipid. So glycerol molecule here with one fatty acid, two fatty acids. One fatty acid is here, so this, and then our OH here. This second fatty acid can be different from the first, or they can be the same as we have been seeing. Then the third fatty acid is substituted by the phosphate, a phosphate that is being derived from P, a phosphate which is in this format. That is the structure of a phosphate. It has 3 OH groups. It's a phosphate which is in that format. Still, it is a condensation reaction. 3 water molecules are going to be lost for formation of a single phospholipid. So it means this gets lost to create an ester bond. That one gets lost to create an ester bond. Even this gets lost now to create a phosphobond between the carbon atom and the phosphate. So we shall come up with a structure which will be in format of, so I want to put the phosphate this way. So the phosphobond is there. Then, of course, hydrogen is there. This is hydrogen. Then the ester bond between the fatty acids and the glycerol are there. So these are hydrogens. So that would be our phospholipid, how it would look like. So as you can see, this phospholipid brings into the lipid, this conjugated lipid, a new property. We had said earlier on that fats and lipids are both insoluble in water, but the phospholipid comes in with a very unique property that is very crucial in body systems. Very, very crucial in body systems. So let's see behavior of a phospholipid. Behavior of a phospholipid. This phospholipid, this part here, is soluble in water. The glycerol backbone plus the fatty acid chain is insoluble in water. So because of that, a phospholipid has a head made up of a phosphate group that is water soluble, called hydrophilic head. So the head will be hydrophilic. Then a tail made up of the fatty chain, the fatty acid chain, insoluble in water, and it is called hydrophobic water repelling. So because of this, a phospholipid, now we can call it, so we can say, therefore, a phospholipid is said to be amphipathic. A phospholipid is said to be amphipathic because it has two regions, a head which is hydrophilic and a tail which is hydrophobic. So a phospholipid in cell biology is represented like that, with a small, let's say, head here, a small is represented in that format. This would be the hydrophobic tail and the hydrophilic head, plus the neck made up of the glycerol molecule. So because of that, if put in water, the phospholipid if this is water, the phospholipid would orientate itself in that way, with the head towards water and the tail away from water. So the main thing, although it has a head which is hydrophilic and a tail which is hydrophobic, the hydrophobic tail outweighs this property, and therefore the water molecule almost behaves as being insoluble in water, but it forms some surface bonds with water between these hydroxyl groups here plus the water molecule. So in cell biology we shall go further and see how useful phospholipids are in the cell membrane. But for now, as chemicals of life, they are very necessary in the formation of cell membranes. That's their main use as biological molecules, very vital components of the cell membrane that make the cell membrane even semi-permeable. We shall discuss it further in cell biology. So in our subsequent, let's look at the next lipid-related compound, the steroids.